In this video, we're going to look at normal distributions and talk about how to do some of the most common calculations. This is going to be probably 2 or 3 video series. And in this first video, what I'm going to do is show you how to answer the most basic kind of question about a normal distribution. And that is, if I give you some x value, and here we're looking at the normal distribution for IQ, which has a mean of 100 here in the middle and a standard deviation of 15, you have to know for any normal distribution those two numbers before you can even get started. And so with a mean of 100 and a standard deviation of 15, you might want to know, for example, what percentage of people have an IQ over, 120, for example. So here's 120. What percentage of people have an IQ over that? Now, when we say what percentage, when we're modeling IQ as this bell-shaped normal distribution here with a mean of 100 and a standard deviation of 15, then that probability or that percentage is going to correlate to what part of the area of this shape is over here, 120 and higher. And so the total area under the curve equals 1, which means 100%. And if we want the probability somebody's over 120, then we want to know what this area is over here. So how do we find that? Well, before we do that problem, let's come back to that problem at the end. Let's start with a simpler problem. In a previous video, or if you haven't watched my previous videos, you may have heard of the empirical rule for bell-shaped distributions. And the empirical rule for bell-shaped distributions assumes we're talking about a normal distribution. And it says, it has 3 parts, but let's just look at the first part. It says that if you go out to 1 standard deviation above, that's 100 plus 15, 115, and you go to 1 standard deviation below, that would be 100 minus 15, or 85, then there's about, now different people teach this different ways, but there's about either, some people say about 2/3 of the data, some people say there's about 68% of the data. I use the accurate number to 2 decimal places, which is there should be about 68.26% of people should have an IQ between 85 and 115, people in the entire population. Now, if you're looking at a population of people with degrees in rocket science, this is not going to be true. But this is, in the overall population, that should be true. Where does this 68% number come from? Let's explore that first. Now, when you're doing this kind of problem, and I'm giving you what we call an x is something here on the x-axis, which is an IQ in this case. I'm giving you an x and I'm asking you, show me that this is the probability of being between those two numbers. How do we get that answer? Well, this is a kind of problem that I call a forward problem. Well, why a forward problem? Well, because there are also backward problems, which I will address in the next video. A forward problem is one I call, I don't know that anybody else on the planet calls them this, but this is just for you to think about. A forward problem is given x, find a probability. So given an x, find a probability. And I'm going to give you a 4-step method that, again, this is a 4-step method that I use when I teach people to do this. And it's going to be useful for forward and backward problems. So a forward problem, I give you an IQ and I ask you some probability. It could be what percentage of people are greater than 120. It could be what percentage of people are less than 85. Or it could be what percentage of people are between 85 and 115. That's the problem we're really trying to get at right now. Here's my 4 steps that I use to try to get at answering this question. Let me use a nice color to look at here. I'll just use regular black. The first step I always do is I draw a picture of what is the problem asking. I'm a very visual person, so I find that drawing a picture helps me really think about what's going on. The second step in this problem, we're going to have to calculate z-scores. A z-score tells us how many standard deviations a number is away from the average. For example, this number right here, 85, has a z-score of -1. Why? Before we talk about calculating them, why? Well, because it's 15 away from average. So that's exactly one standard deviation. So let me write that one. Z equals -1. It's one standard deviation away from average, and since it's one standard deviation below average, it's a -1. So that's what a z-score tells you. How many standard deviations away from average are you? For example, another z-score down here would be for the number 70. Since that's 30 below 100, and the standard deviation for IQ is 15, that's 2 standard deviations below the mean. That would have a z-score of -2. Okay, so you get the idea? 115 would have a z-score of +1. That's kind of obvious to see. Now, how do you calculate a z-score if it's not an obvious case? Well, there's a little formula here that z is equal to the x number, an IQ, minus the average IQ divided by the standard deviation. So, for example, let's just look at that 85 and how that would work. You take 85 minus 100 over 15. That's going to give you -15 over 15 equals -1. Okay? And similarly for 115. So in general, calculate z-scores for the numbers that you're given. The third step, what we're going to do is we're going to take the z-score to a table. And so you need to have a calculator and a z-score table in front of you. And if you don't have one, I have one on my website. I'll show you in just a second, and I'll tell you how to get it. So take the z to the table. Let's have a look at this table. Now, if you don't have a z-score table and you need one, they're easy to find on the internet. If you can't find one, or if you want the same one I use, then go to www.berkeyacademy.com. Click on Files. On the left-hand side, you'll see some items, and one of them is Files. If you click on Files, then look for a file called normal table, basically, NORM, norm tab.pdf. I recommend you download that, print it out so that you have it in front of you. Pause the video if you don't have one. Otherwise, let's just look at this normal table here real quickly. Let me introduce you to it. This is a normal table that I made in Excel, and it is a standardized cumulative normal distribution table. What does that mean? The word standardized here means that the table we're looking at, and I put a picture right here for you, the table we're looking at is for a normal distribution that has a mean of 0 and a standard deviation. Each of these tick marks here is 1, and the standard deviation is 1. And you can always, on a picture, see where one standard deviation is away by looking at where the curve stops getting steeper, 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 and starts getting flatter, flatter, flatter. We call that an inflection point, and it's right in there where that number 1, since the standard deviation is 1 on this table, that's one standard deviation away. So on this table, the z-scores are also the numbers on the x-axis, since the mean is 0 and the standard deviation is 1. Because when you calculate a z-score, you subtract the mean. Well, we're just subtracting 0, and then we divide by the standard deviation, which is 1, and that doesn't change the numbers. So how do you use this table? Well, in this problem, we have two z-scores we might want to look up to find this number in the middle, right? We have a z-score of -1. When you use a table, you always want to round these z-scores to 2 decimal places. So let me just add 0.00 on the end there, because this table is accurate to 2 decimal places. So how does this table work? Let me zoom out a little bit here. Negative z-scores are on the left side, and they're listed in this column along the left. Positive z-scores are, the probabilities are given on the right side, and the positive z-scores are listed in this kind of middle column here. The first two decimal places are listed in the column, and then the second decimal place are listed in this column. The second decimal place you look up in these columns as you go to the right. 0.00, 0.01, 0.02, 0.03, 0.04. For example, let's look up that minus 1.00. So I'm zooming in here so you can see. You look up the first two digits, minus 1.0, and then the first column is for 0.00. The second decimal place is 0, and that gives us this 0.1587 here. Let's take that back to the picture and see what that gives us, keeping in mind that this is a cumulative table. What a cumulative table means is the table will always give you the probability of being less than. It accumulates the probability from the lowest numbers up to the number that you're looking at, a z-score of 1 or an IQ of 85 in this case. So that 0.1587 is the area right here, 0.1587. So if this question were asking us, so we take the z to the table, let me just fill that in there. We take the z to the table, and what the table will always give us is a less than probability. Always give us a less than probability. The fourth step in my four-step method is to go back to the picture to figure out the final answer. So as I was saying, if this question had asked us, what is the probability of having an IQ less than 85, we'd be done. But we're not done, because what I was trying to do is figure out, where does this 68.26% come from? Now certainly this can help us in getting that. Now, what should we do next? Well, let me give you two ways. First way, since we have two numbers, 85 and 115, when you have a between problem, let me erase the final answer here so we can pretend we don't know it. We have two z-scores. We should probably look up this z-score of 1. Let's go back to the table and look up a positive 1 z-score. So let me zoom out. Positive z-scores on the right. So we go down to 1.0. 1.0 in the second decimal place, O also. We'll look up some with that don't just have zeros in the last two places here in a second. So 0.8413 is the probability. Let's go back to our picture. Keep in mind that's a less than probability. So what does that mean? Well, the probability of being less than, and I usually draw a long arrow, less than an IQ of 115 is that number that we had in the table, 0.8413 there. So let's put that here, 0.8413. I'm drawing that really large, and I'm trying to overlap it so we can really picture that this 0.8413 includes the area here in the middle, and it also includes this area on the left side below 85. It includes all the area on the left. So if we want to figure out how much is in the middle, how could we do that? Well, the way I picture doing this, let me use green here, is the 0.8413 is the probability of having an IQ less than 115. That's all this area on the left. What we really want to do is chop off this area on this side. We want to chop off or subtract off that 16% almost that's right down there. So when you have an in-between problem, the way we normally think about doing it is take the 0.8413, subtract off that 0.1587, And what that's going to give you is the area that's just left here in the middle, which is the 0.6826. And that's where that 68.26% probability of being within or between plus and minus 1 standard deviation comes from. So when you look up a z-score, you get the less than probability. If you want a between answer, look up 2 z-scores and subtract the smaller one from the larger one. Okay? Let's do one more problem here. The other kind of problem you can have that's like this, let me clean this up a little bit, is a greater than problem. How would you figure out the first question that I asked at the beginning of our talk? What percent of people have an IQ above 120? So first I'm going to, first step, draw my picture. That's the probability I'm looking for. Second step, calculate a z-score. Okay, well, the x value is 120. Let me clean up some of this stuff here. So 120 minus the mean, always 100, at least if we're talking about IQ, and then divide that by the standard deviation of 15. And we get a z-score of 1.33. Let's go to the table and see what we find. So again, this is a z-score that's positive, so we're going to look on the right side here. And 1.33, here's the first decimal, the whole number in the first decimal, 1.3. This would be 1.3, let me bring this down so you can see the column headings. 1.30, 1.31, 1.32, 1.33, 0.9082. So let's take that 0.9082 back to the picture. Keep in mind, the table always gives you less than probabilities. And so this big area, this tells us that 90.82% of people have an IQ less than 120. So therefore, what percentage of people have an IQ greater than 120? Well, we can use the complement rule. In other words, if everything is 100%, or 1, and 0.9082 is here, subtract 1 minus 0.9082, and that'll give you the area on the right. So that answer is going to be 0.0918. Now, we're about done with most of the fundamentals here, but let me just mention a couple of other things quickly to wrap up. Always keep in mind when you're doing these problems that the mean is also the median. Now, what does that mean? Well, the median is the number that splits this into 50% on the right and 50% on the left. And so sometimes you can use that to either check your answer, or sometimes you can use that to help find your answer. For example, we know that if there's only 50% on the right, that this answer, 0.0918, what percentage of people have, 9.18%, what percentage of people have an IQ greater than 120, we know that answer has to be quite a bit less than 50%, because this is kind of a small subset of the entire 50% that's above 100. Another thing to notice here is that this bell-shaped curve is symmetric. Symmetric means that if you took it at the median and you folded it over in half, that the left side looks precisely like the right side. It's a mirror image, in other words. Sometimes a shortcut that you can use, but only do this if you're comfortable with this idea, but sometimes a shortcut you can use is to say that, well, if I'm looking for the probability of being greater than 120, or greater than a z-score of 1.33, then the mirror image picture of this would be if we went over on the left-hand side to 80. Why 80? Well, 120 is 20 above the mean, and 80 is 20 below the mean. And so this area over here has got to be the same as this area over here. It looks like it's the same shape, just kind of flipped. Also true is that if this is a z-score of plus 1.33, that this z-score must be negative 1.33. And we can verify that. 80 minus 100 over 15 is indeed going to give us a z-score. Let me erase this z-score of 1 so we're not confused. Is going to give us a z-score of negative 1.33. So a slight shortcut would be to say, well, there are two ways to get this greater than area. One way would be to say, look up the z-score of 1.33, realize that what we look up, that 0.9082, is less than that, and then subtract. Another way would just be to go to the table and look up the negative. Because when you look up a negative z-score, it automatically gives you this area of less than, the probability of being less than that. And so if we go to the z table and we look up a negative 1.3, here's 1.30, 1.31, 1.32, 1.33, that gives us that 0.0918 directly without having to write down that intermediate step and then subtract from 1. We just get the final answer kind of automatically, 0.0918. So this is kind of a little bit more advanced trick, but if you see the idea that I'm telling you, anytime you can save a step and you're comfortable that you're confident that you're doing the right thing there, why not use that kind of trick? So we're using the symmetry of the normal distribution to our advantage. In the next video, what I'm going to do is show you how to solve what I call a backwards problem. So a forward problem is you're given some x, in this case an IQ, and you're asked to find the probability or the percentage of people in that area or percentage of things in that area. A backward problem would be something like this. Suppose you wanted to start a high IQ club. And we know that 9.18% of people have an IQ over 120. Suppose you wanted to start a high IQ club that was a little more exclusive than this. And you said, well, I don't want to set my entrance level at an IQ of 120. I want to set it higher so that only 5% of people, it's going to be something greater than 120. We don't know what, but we want 5%, 0.05 of the area to be there. And you're asked, what IQ would that be? So a backward problem, you're given a probability and asked to find the x or find the IQ. We'll do that in the next video.